Okay, before we get started, you should have your notes handout of this whenever or before you come to class. You need to have that filled out. So make sure that you are filling in the blanks as you go along. If you need to pause the video, you can do that. So I'm basically just reading through this with you. Arithmetic sequences. We talked about sequences a little bit. But the terms are just the numbers themselves in the sequence. So 1 would be the first term, and 10 would be the, what is that, 1, 2, 3, 4, fifth term. Arithmetic sequences are sequences that have a common difference. That means that they're adding or subtracting each time. So as you see from 4 to 9 and to 9 to 14 and so on, we're only adding or subtracting. And in this case, we are adding. We're never multiplying or dividing. That's geometric sequences, which we have not gotten to yet. And here the common difference is 5, and that's going to be important for the formula that we're going to see in just a minute. How do you know if it is an arithmetic sequence? Like I just said, it will have to have a common difference, so it has to be adding or subtracting by the same number each time. So this first one is not, because 2 to 4 is going up by 2, but from 4 to 8 it's going up by 4. So basically we're doubling or multiplying, so that's why this first one is not an arithmetic sequence. It is not addition. And the second one is because we are adding -3 or subtracting 3 each time from each term. Finding the subsequent or the next terms in the sequence. First, we have to find out what the common difference is. So here from 2 to 5 to 8 to 11, you notice that it's going up by 3 each time. So you're simply just going to add to 14 to the last term that we had to get 17, and then add to 3 to 17 to get 20, add 3 to that to get 23. So our common difference is 3. Finding the nth term, that's just a way to say we're finding whatever term it is that we're asking for. It's kind of like saying x. So here we're looking at the formula. This is the recursive formula for arithmetic sequences, where this part, a sub 1, is just talking about the first term in the sequence. So if we said 2, 4, 6, 8, a sub 1 would be 2, because that's the first number in the sequence, in the pattern. And then n is whatever number we're looking for. So if we're looking for the fifth term, then n would be 5. And d represents the common difference, whatever we are adding or subtracting to each term in the sequence. So those vocabulary are going to be important for you to know to be able to use the formula. Oh, let me go back one. All right, so this example, if we're going to find the 25th term of the sequence, we could either keep adding 5 each time, or subtracting 6. That's our common difference. We could subtract 6 each time, which would take us a while, or we could use the formula. So here are your steps. You're going to find the common difference first. So obviously that's 6, because we are adding 6 each time. So that was our first step, finding the common difference, which is just taking your second term, 11, the second number in the sequence, and subtracting by the first term, 5, to get our common difference, 6. And you can see it's going up by 6 each time. And then we're going to plug our information into our formula. So the first term was 5. That was the first number in the list of numbers. So we're going to put 5 here. N, we're looking for the 25th term. So n will be 25. Minus 1 is always just part of the formula, times the common difference, which was 6. So of course PEMDAS applies. You have to do parentheses first to get 24, and multiply 24 by 6, and then add 5. And the 25th term if we were to keep adding up to the 25th number, we would get 149. Here's another example. If we're finding the 17th term, again, same thing, we're finding the common difference. So looking at our first two numbers, 13 minus 26 is negative 13, so we're going down. We're adding a negative number or we're subtracting. So that's going to be our D. The A sub 1 is 26, that's the first number. And we are looking for the 17th term, so N is going to be 17. Plug in all our information into our formula, do PEMDAS, and we get negative 182. And again, make sure you are filling in your notes as you're going along. Pause the video if you need to. Here's an example where you have to work backwards. So we want to find the first term in the sequence if we know what the 9th term is and we know what the common difference is. So we're working with one unknown or one variable. So we know that the 9th term, or N, is 72. We know the common difference is 5. What we were looking for, or our X, if you want to call it that, is A sub 1. What is the first number in this sequence? So we're just working backwards. 9 minus 1 is 8. Then we have to do 8 times 5, which gives us 40. And then, of course, we're solving equations now for our variable. So the opposite of adding 40 would be subtracting 40 from 72. And that's how we get the first term in our sequence, which is 32. All right, here is an application problem, so a word problem. Suppose you have started saving. You've saved $75 towards the purchase of a new tablet. You plan to save at least $12 for mowing your neighbor's lawn each week. In all, what is the minimum amount of money you will have in 26 weeks? So again, we're finding our common difference. And that in this case is our rate, which is $12 each week. So that's what we're going to be adding to our savings. And then what did we start with? We started with saving $75. So that was at week 0 when we had not mowed any lawns yet. We started with 75. And then we are going to put 27 in here instead of 26, because we have to start with the previous term. Or if you read this part right here, the first term in the sequence, 75, came before the weeks started. So think of that as week 0. We started with $75 at week 0. Therefore, you want one more week in your formula to account for the $75 that you had before you started. So if we simplify that expression, we are going to get $387 saved in 26 weeks. And that is it. Go back, pause it if you need to for your notes.